All right, let's go through the chapter 2 sample test. So, giving you this graph, and it has an open circle on this piece, and it says to talk about the continuity, including left, right, and if not both. Okay, so the reason, let's talk about this. First of all, left continuity. So the left side of this is not continuous because it goes to an open circle. It does have a limit. I didn't ask you to do that, but you might want to talk about the left limit appears to be one. Right side is not continuous because it heads off to negative infinity, so it never reaches to x equal 2. And it has no limit. So there is no limit in general because it has to have left limit and right limit, and they need to be equal. Okay, so that answers the stuff about the left hand and right hand continuity, and even some more about limits, which would be nice. Also, what appears to be the limit as x approaches infinity? As x approaches infinity, so as we go out here, it looks like the y height is approaching a value of 1. The limit as x approaches infinity appears to be of graph, because the limit's always of something. I almost made the mistake, I didn't want you to, of the graph, equals 1. Because the graph appears to approach y equal 1. Okay. I threw this limit stuff in here just in case I change this question to say not talking about continuity, but maybe talk about limits. Okay? Number 2, numerical methods to estimate the limit. So if you pull out your calculator and type this into the y1, making sure that I put the numerator in parentheses 5 to the x minus 25, close parenthesis, divided by 49, I better start that with a parenthesis. Parenthesis 49 minus 7 to the x. And we're looking at where x approaches 2. Well, where it approaches 2, close parentheses, that would be 25 minus 25, which would go to 0, and 49 minus 49, which would be 0. So they're both going to 0. So this is indeterminate. So now I would just go to second table and clear these things and look close to 2. So 1.9 gives me negative. So I'll put in show my work here by putting 1.9 gives negative 0.4289. 1.99 approaches negative 0.4289. Not change. Oop. Enter. I didn't do it. 4.227. Let's go to 4 nines. 1.9999. 1.9999 approaches negative 0.422. Okay, let's come in from the other side, just in case it does something completely different on the other side. So I'm going to put in 2.01. I'll start with that one. 2.01, and that approaches negative 4.4213. And 2.0001, 2.0001, that's getting really close, and that's negative 0.422. So it looks like I would have to say the limit of this, limit as x approaches 2 of 5 to the x minus 25 over 49 minus 7 to the x appears to be negative 0.422. And I showed my work. And number 3, I actually made a mistake on this when I wrote this one. If you put 2 in, you get not 0, not 0. So you can just say the limit would be square root of 2 minus 2 over 2 minus 4. But that's not what I wanted you to do here. So that would be the answer to this one, which you could write as a decimal or leave it like that. That would be square root of 2 minus 2 over negative 2. What I wanted to do the limit of is as t approached 4. So now let's see what that would look like. If I put 4 in the numerator would be the square root of 4, 2 minus 2, which is 0. And the denominator would be 0. So it would be indeterminate. So then we would do, we would have to do something to this to try to be able to solve this. So the limit as square root of t minus 2 over t minus 4 as t approaches 4. Two possible ways to do this. We've talked about both in class. First was to multiply by the conjugate, which would be the square root of t plus 2 and the square root of t plus 2. Multiply the numerator and denominator by that. And that would give us the limit as t approaches 4 of t minus 4 over t minus 4 times the square root of t plus 2, which would be the limit as t approaches 4. These would cancel out and be 1 over the square root of t plus 2, which becomes 1 over the square root of 4 plus 2, or 1/4. The other that we've talked about in class would be to factor the denominator. And so that would be the square root of 2 minus 2, t minus 2 in the numerator over square root of t plus 2 and the square root of t minus 2. And the square root of t minus 2 would cancel, and we'd have the limit as t approaches 4 of 1 over the square root of t plus 2, which would take us back to there. Okay, that's 3. 4 is just an algebra problem with a touch of calculus. So we have the limit as h approaches 0 of this. So we have a plus h squared times a 2. So it would be 2, and a plus h squared would be a squared plus 2ah plus h squared plus 3a plus 3h minus 2a squared, and that minus distributes and makes minus 3a. All of that over h, which becomes the limit as h approaches 0 of 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 2a squared minus 3a all over h. That simplifies to the 2a squareds and the cancel, the plus 3a and the minus 3a cancel, and we have 4ah plus 2h squared plus 3h left over h, which becomes the limit as h approaches 0 of h times 4a plus 2h plus 3 close parentheses over h. And here the h's cancel, so now I can take the limit, putting 0 in for the h, and I get 4a plus 3. Number 5. All right, can I put 2 in? That gives me 0 in the denominator. It gives me 8 minus 8, 0 in the numerator. So indeterminate. So we get the limit as x approaches 2. If I factor the numerator, I can factor out an x, and I get x times x squared minus 4 over x minus 2. Do some more factoring. X times x plus 2 times x minus 2 over x minus 2, and the x minus 2's cancel, and I get the limit as x approaches 2 of x times x plus 2, which I can take the limit of by substitution and get 2 times 2 plus 2, which is 8. All right. Now this says the limit of the log of the sine of this. If I put 2 in here, I get the sine of pi over 2, which is 1, and log of 1 I can do. So I can do this limit just by substitution. It becomes the natural log of the sine of pi over 2. The sine of pi over 2 is 1. The natural log of 1 is 0. I'm done. Seven. This sort of looks like one of our rule. It looks like the rule that says the limit as theta goes to 0 of 1 minus cosine theta over theta, which is 0. So if that's 0, switching them, if that means the cosine theta has to be 1, so 1 minus cosine theta or cosine theta minus 1 shouldn't make any difference. So if I can somehow get this out of this, I'd be happy. Maybe I can go somewhere with it. So I'm going to look at this. Or the other thing I can do is look at whether this is even indeterminate. Now, what's the denominator do? Well, it goes to 0. What's the numerator go to? Well, that'd be 1 minus 2, which is not 0. So this isn't indeterminate. So this probably doesn't have a limit. And I could say no limit because it's not indeterminate right now and be done. But let's just kind of look at it a little bit more here, just so we understand a little bit more about why that's true. So I could write this as cosine theta minus 1 minus another 1. And all that's over theta, so I could write this part over theta and this part over theta. Common denominator, so I would combine these two and I would get exactly what I had before. So this becomes the limit as theta approaches 0 of cosine theta minus 1 over 0 plus the limit as theta approaches 0 of minus 1 over theta, and this has no limit. It goes off to positive or negative infinity depending on which side you come in. So this has no limit. So the whole thing has no limit. But I'll go back and say no limit because indeterminate. It doesn't go to 0 in the numerator when the denominator does. The next one. All right, so how does this work? Well, I'm coming in from the negative side towards -3. From the negative side. So I'm coming this way towards a -3. So I might have -4, -5. So this becomes the limit as x approaches -3 from the negative side. When I come from the negative side, absolute value of like -3.1 or -3.2 minus plus 3 is going to be the limit of a negative, and it will change the sign. So this becomes that absolute value is going to, for all these numbers on this side of -3, the absolute value would actually change the sign of this whole quantity. So I can replace the absolute value with negative of x plus 3. The absolute value would change those signs. If I was on the positive side of -3, it wouldn't change them, and I would leave that out. But since I'm coming from the -3 side, that's what we have over x plus 3, which then these cancel out, and I have the limit as x approaches -3 from the negative side of -1, which is -1. All right, this one. What happens as we approach -infinity? Well, cube roots, we can do -infinity. We got stuff here, so let's talk about this one here. So we want to see what the limit as x approaches negative infinity of the 2x minus 1 over cube root of 6 minus 125 x to the third. Well, as x goes towards negative infinity, x is, and I should say is very small, or is large in size but negative, which means very, very small. This, it goes towards looks like we've got to look at the ruling powers here. So the minus 1 becomes negative 1 is insignificant, and so is the 6 in the root, and so is the 6. So we get 2x over, and the cube root of negative 125 is negative 5, and the cube root of x to the third is x. Well, in this, the x's would cancel, and we would get the limit as x approaches negative infinity of negative 2/5, which is negative 2/5. And now, number 9. Find the limit of this. Well, the angles are 4x, and here's only x. Because as x approaches 0, 4x approaches 0, we can write the limit of 4x approach 0 of cosine 4x over x times the cotangent, which is cosine 4x over sine 4x. Little trig identity. And now we can make a substitution. Let theta be 4x, and this becomes the limit. We're going to do a couple things here. So the 4x becomes theta approaches 0 of cosine theta over x. See, if let then theta divided by 4 is what x is if we solve for x in this. So we got replace the x with theta over 4 times cosine theta over sine theta. And now let's take a look at what that is. So I'll invert these fractions in the denominator. I'll invert and multiply them. So I get the limit as x approaches 0 of cosine theta over, and then I'd have the 4, and the sine theta would multiply times the numerator, times 4 times sine theta over theta and cosine theta. So that's invert and multiply, so the 4 sine theta goes in the numerator, and those stay right there in the denominator. Now, the cosine thetas cancel. The 4 comes out, and so we get 4 limit as x approaches 0, or theta approaches 0, excuse me, theta approaches 0, of sine theta over theta, which we know this part is 1, so we have 4 times 1, which is 4. 10. If the height of the object is determined by this equation, that's h of t is negative 16t squared plus 64t. So that's in feet. The height is h is in feet and t in seconds. Determine the average velocity. Well, the height at 1 is 1 times negative 16. Negative 16 plus 1 times 64. 64 is 48 feet. The height at 2, 4 times 16 is negative 64, plus 2 times 64 is 128, so that becomes 64 feet. So the average would be the change in distance. That's a change of 16. 3/16, 4/16, make sure. 16, 4, yeah. So that's a change in height of 16, a plus 16 feet in 1 second. That's 64 minus 48 over 2 minus 1, which is 16 feet per second. Feet per second is a velocity. Okay, now estimate the instantaneous speed at 1. So we can do this either by moving the 2 closer and closer to 1 in our calculator, doing all these calculations, or we can just do another way to estimate it at really close to 1 would be to use the height just before 1 and just the height just after 1. So I could figure out the height at 0.99 seconds and figure out the height at 1.01 seconds and then do the slope between these 2 points. So we can do it either way. So I'm going to turn on my calculator. I'm going to do y equal. I'm going to clear that equation and put in negative 16x squared plus 64x. And then in y2, I'm going to do the slope. So I'm going to actually figure out the slope between 1 and a little bit past 1 or a little bit before. Now the slope will be, let's do it between, I'll do this way first. H of 1, at 1 point, a little bit more than 1, so I'll call that x, minus h of 1 over x minus 1. Understand? So that would be the height at a time slightly past 1 minus the time at 1 over x minus 1. So I'm going to do that first, and I'll show you this one. So this would be vars y variable, function variable, y1 at x, parenthesis x. Oop, I need to put a parenthesis around my numerator. Oop, second, insert a paren. Minus vars, y vars function y1 at 1, close parenthesis for the numerator, divided by x minus 1. Oop, in parentheses. Parenthesis x minus 1, close parenthesis. Now I can go to my table and put numbers really close to 1 on the positive side there or the negative side and get an idea what this is going to do. So I'm going to go to second table. Once again, I have it on auto ask, so I'm going to delete all this stuff here. And I don't really care what y1 is. That'll be the height. I want to know the slope. So I'm going to put in something really close to 1, 1.1, and I get a slope of 30.4. as the velocity. If I do 1.001, I get 31.984. Now if I get closer, 1.00001, I get, it calculator rounds this off, but I put in 1.0001 and I got 32. So I'm guessing it's getting closer to there. Now I can go to the negative side too. 0.999, which is pretty close, 0.999, and I get 32.016. But if I go 0.99999, I did 5 of them, 0.99999, it gives me the change of 32. So I get the slope to be 32 meters or feet per second. Okay, now let's do it this way. Now I'll just show you how that works. So I can go to y1, and now instead of putting x and something here, I'm going to go, I'm going to make it, change the x to x plus, second insert a plus 1, and then I'm going to do an x, so x is how much I'm going to add to the 1 to be a little bit above it, and x is also going to be how much I subtract to get a little bit below 1, so I'm going to go 1 second insert minus 1 over, and the x is just how much off I am, so that'll be the change. So if I'm, x is a little bit more than, and that was supposed to be x1 minus x. X is how much below and above, and so the difference will be 2x. So I'm going to put down in the denominator x times 2, because I'm whatever I put in for x, a little bit below 1 and a little bit above 1. So now I'm going to go to my table, and x is how far off of 1 I'm going to be. So I got to get rid of all these. I want to be close to 1, so I'll put in 0.1. So I'm figuring out the slope for between 1.1 and 0.9, and it says 32. Now notice that I get the 32 even though I'm 0.1 off on either side. Now if I even get closer, 0.01 still says 32, and 0.0001 I'm still getting 32. I can be fairly far off. Let's try 0.2, and it says 32. 0.3 still says 32. 0.4 still says 32. I have to be quite a bit off. Let's say I'm 1 off. I get 32. If I do 2 away, I still get 32. If I'm 4 away, I still get 32. So anyway, you can do either method, but the answer is 32 feet per second. And that's it.